Right, so with this question here now, it says the distance time graph shows a 140-kilometre journey from Meadow Green to Town Close. What is the distance travelled between 1300 and 1430? Okay, so it's important to recognise here that this is a distance time graph, okay? So it's a travel graph, ultimately, okay? It's not a velocity time graph, it's a travel graph with distance against time. But of course we've got a curve here, okay, because the speeds are obviously changing, right? And to work out the distance travelled between these two times, you just got to look at what the distance is at these two particular times. Okay, so at the time of 1300, okay, 1 o'clock, okay, we can read across there. We can have a look when it hits the curve, what that is. So you can see here 60 something, okay, and each square I think is going up in 4s because there's 5 squares here for a gap of 20. So each square is going up in 4s, so that'll be 64, okay? And at 1430, which is here, okay, so let's look at what distance is at 1430. It is that value there, which is, again, 4, so 4 back will be 116. So work out the distances that travel between those times, okay? So we're interested in between those times. Of course, you've got to take it away. So he's gone from 64 to 116. So you take it away, use your calculator, it comes out as 52 kilometers. Okay, so that's the distance. Part 2 then, part 2 is linked to part 1 because it's all in part A here. It says find the average speed for this part of the journey. So when it says for this part of the journey, okay, they're not talking about the whole journey, right? They're not talking about the whole journey. They're only talking about the part of the journey between 1300 and 1430. Okay, and it's clear because it's linked, right? It's question A, but it's 1 and 2. It's all linked. It's all into part A here, right? 2 is linked to 1, and because it's all in part A. We haven't gone to part B yet. It's related to this. Okay, to get the average speed, don't forget, use your formula. Speed is distance over time. Okay, so the speed is the distance, which is 52. Divide by the time. Now from 1 o'clock to 1430 is 1.5 hours, okay, and you want to write that as 1.5. okay, don't change it to minutes. Okay, some people would change it to minutes. Don't do that because you divide it by 90, but you don't want kilometers per minute, you want kilometers per hour. So I work it out on my calculator, okay, and it comes to 34.6 recurring. So you can maybe round that there. Of course that means with the doctors 666s and so on, we'd round it 1 decimal place or 2 decimal places, okay, no harm there, and that's kilometers per hour. Alright, part B then, it says explain how you can tell from the graph that it took less time to travel the first 70 kilometers of the journey than it took to travel the final 70 kilometers. So you look at the first 70 kilometers, okay, which takes you to about there, okay, you can see the shape of the graph, and when you look at the final 70 kilometers then you can see the shape of the graph. If you notice, it's starting to, I mean, it's still steep, but it's much more flatter compared to this steepness. This part of the first 70 here is much steeper, okay, than this here. It is much steeper here, it's almost vertical here, okay, but here it's not so vertical, and it really does start to flatten out. Okay, so you could say it took less time. Oh, don't 3 O's. It took less time because the gradient in the first half, for the first 70 kilometers, is greater. Okay, and to expand on that, you say, i.e., it is steeper. Okay.